Hello everyone. Today we'll be going over Chapter 8, otherwise known as confidence intervals. Here's the outline for this chapter. This chapter is broken down into two parts, confidence intervals and sample size and margin of error. Each of the two parts is broken down into three subcategories, the first of which is called z-scores, the second being called t-tables, and the third being called proportions, each of the three representing a different method to solve each category. Here we have a chart. The chart helps you identify which method to use, and we'll go over it together. The first question you have to ask yourself is our sample size n greater than or equal to 50? If the case is yes, use the z-score method. If the case is no, ask yourself a second question. Is the standard deviation of the population given? If the answer is yes, use z-scores anyways. If the answer is no, use a t-table method. In this chart, we have all the formulas needed for this chapter. The first column is about z-scores, the second is about t-tables, and the third is about proportions. And the first row is for confidence levels, and the second row is for margin of error. The only adjustment that needs to be made is in this last cell, proportions. This margin of error formula should not include standard deviation. Just scratch that out and ignore it. Let us begin with problem 1. Problem 1. According to a recent report, the federal government is requiring local officials to enforce 100 km/h speed limit within their jurisdictions. Accordingly, any province may be in jeopardy of losing millions of dollars in federal road funds if more than 60% of its vehicles are found to be exceeding the speed limit. In one province, 70 radar surveys are conducted each year at a total of 50 different sites in order to estimate the proportion P of vehicles exceeding the 100 km/h speed limit. Each of the samples involve at least 500 vehicles. A. How large of a sample should be selected at site 39 in order to estimate P to within 3% and with 90% confidence? Last year, approximately 60% of all vehicles exceeded the limit. The first step we're going to do is we're going to highlight the important information the problem gives us. They tell us that we're estimating P within 3% with a 90% confidence, and last year 60% of the vehicles exceeded the limit. The problem is asking us to find n, which is unknown. They tell us that the proportion from last year is equivalent to 0.60, and that the confidence level is equal to 90%. Based on the confidence level, we can find the alpha. Alpha is equal to 1 minus 0.9, which gives us 0.1. The formula is asking us to divide it by 2, so we're going to divide the 0.1 by 2, giving us 0.05. And we're going to have to find a z-score equivalent to an alpha over 2 equal to 0.05. To find this value, you have to understand the value of alpha, which basically tells us that this tail is equivalent to 0.05 or 5%. So the z-score we're looking for would have to be a z-score equal to 95% or 0.95, and that value will be 1.645. Once we have these values, we can plug them into our equation. So n equals to 0.6 times 1 minus 0.6 multiplied by our z-score, 1.645, over our error, which was in the problem. It was given to us as 3% or 0.03 squared, and that gives us an n equivalent to 721.6. But since we can't have 0.6 of a vehicle, we have to round it up to 722. And what this means is, in order to estimate P within 3% with 90% confidence, we would need a sample of at least 722 vehicles. Now let's move on to B. The average speed of vehicles on major expressways is also of interest to the government. How large of a sample would be necessary at Site 39 in order to estimate the mean within 0.5 kilometer with 90% confidence? Assume the standard deviation of speeds is approximately 5 kilometers per hour. Again, before we begin, let's highlight the information they give us. They tell us the standard deviation this time is 5 kilometers per hour. They tell us they want to estimate within 0.5 kilometers, which is our margin of error, or our E. And they tell us the confidence level is 90%. Therefore, let's write these values. E equals to 0.5. Our confidence level equals 90%. And our standard deviation is 5 kilometers. We're missing the alpha. So to find the alpha, you have to do 1 minus the confidence level, which is 0.9, and that gives us 0.1. For the formula, we need alpha over 2, so we're going to divide by 2 right away, making it 0.05. And then you'd have to go find on the z-score table a z-score equal to an alpha of 0.05 or 95%, and that'll give us a value of 1.645. And now that we have all the information needed, we can simply plug it into the formula. N equals to 1.645 times 0.5 over our margin of error, our E, which is 0.5. Our standard deviation was actually 5. So just to repeat, it's our z-score of 1.645 times our standard deviation of 5 kilometers per hour divided by our margin of error of 0.5, and that gives us a value of 270.6. Again, you can't have 0.6 of a car, so we have to round up. 271. And what this means is, in order to estimate the mean to within 5 kilometers with 90% confidence, we would need a sample size of at least 271 vehicles. Let us move on to part C. Problem 1C. Set up a 95% confidence interval estimate of the true average speed of vehicles on major highways if the 70 surveys mentioned yield a sample mean equal to 110 kilometers per hour and a standard deviation equal to 6 kilometers per hour. Let us highlight the important information the problem gives us. It gives us the confidence level of 95%, the sample mean of 110 kilometers per hour, and the standard deviation of 6 kilometers per hour. Now looking at the formula, we have the sample mean, which is 110 kilometers per hour. We have the standard deviation, which is equivalent to 6 kilometers per hour. We have our N, which is equivalent to 70 surveys. And we have our confidence level, which is equivalent to 0.95 or 95%. The only value we're missing is the z-score and the alpha. The alpha is equal to 1 minus the confidence level, which gives us 0.05. However, the problem has it divided by 2. So we'll divide it by 2, and that'll give us a value of 0.025. That means we need to find a z-score equivalent to 0.025. To help you understand how to find that, I'm going to graph it. We have our mean in the middle, which is 110. And then we have our alpha, which was originally 0.05. However, since this problem is dealing with two tails, we have to divide it by 2. And that is having 0.025 on each end. And then to find the z-score equivalent to that point, we'd be looking for a z-score that covers this entire area. So it would be 1 minus 0.025 gives us 0.9725. So you'd be looking for a z-score that leaves 97.25% to the left of it. And that'll give you a value or a z-score of 1.96. Once we have that value, we can plug in the values to the formula, and that'll be 110 plus or minus a z-score of 1.96 times a standard deviation of 6 over the square root of our n, which is 70, and that'll give us an interval between 108.59 and 111.406. And what this means is that these values happen to be right at the edges of our distribution, and it could be interpreted as saying that there is a 95% level or confidence level, 95%, that the mean for the entire population will be between those two values based on our estimate of our sample mean of 110. Let us move on to problem 2. Problem 2. Last semester there was a COMM 215 class where 100 students wrote the final exam. The average grade on the final exam for this class was 60% with a standard deviation of 7.5%. In this class of 100 students, there were 7 students who failed the course because they did not achieve the required minimum grade of 40% on the final exam. Assuming this class to be representative of all students writing the COMM 215 final exam last semester, determine the following. A 95% confidence interval for the true average grade on the COMM 215 final exam. Before we start the problem, let's highlight the information they give us. They tell us that the average grade for this class was 60% and the standard deviation was 7.5%. They also tell us that 100 students are in this class. And then 8 tells us that the confidence level is 95%. So let's just rewrite those numbers. The average of the class was 60% or 0.60. Actually, we'll just leave it as 60%. The standard deviation was equal to 7.5%. There were 100 students, so our n is equal to 100, and our confidence level equals 95%. Again, by looking at the formula, we have our x, but we don't have our z or our alpha. So to find the alpha, we do 1 minus the confidence level, which is 0.95, which gives us 0.05, divided by 2, since we have to for the problem, and that gives us 0.025. Then we need to go find a z-score equivalent to an alpha of 0.025, and that'll give us a value of 1.96. And now we have all the problems or all the numbers needed to solve our problem. Let us begin. Our mean is 60, plus or minus the z-score of 1.96 multiplied by the standard deviation over the square root of our sample size, which is 100, and this will give us an interval between 58.53% to 61.47%. And what this means is, look at the distribution. Our sample had a mean of 60%. However, the sample mean is not always the same as the population mean. But using the math we just did, we found the confidence level, meaning that we are 95% sure that the real mean for the entire population falls within 58.53% and 61.47%, with an error margin of 5% in all, or 0.025 on either end. Let's move on to problem 2, part B. B. A 95% confidence interval for the true proportion of students failing COMM 215 last semester because they did not achieve the minimum grade requirement of 40%. Now for this number, we need to get some values that we had in the previous question, or the previous part, and they were relevant to the students who failed. The problem tells us that out of 100 students, 7 students failed the exam. So we translate that here. That means the proportion of students who fail are 0.07, which I found by taking 7, the number of students who failed, over all the students in the class. The confidence level has not changed. It's still 95% is our confidence. And our n has also not changed, which is still 100. Given that our confidence has not changed, our alpha from the previous problem is the same, which was found by doing 1 minus 0.95%, gives us 0.05 divided by 2. Our alpha must be divided by 2. Gives us 0.025. And our z-score, equivalent to an alpha of 0.025, is equal to 1.96. Now that we have all the values we need, we're going to plug it into the equation, which will give us P, which is equivalent to 0.07, plus or minus the z-score of alpha over 2, which is 1.96, times the square root of P, 0.07, times 1 minus 0.07 over n, which is our sample size, 100, and that gives us a confidence interval of 0.02 to 0.12. What this represents is the proportion of the sample we have is 0.07, meaning in the class we sampled, 7% failed, and it gives us these confidence interval, which is 95%, which means we are 95% sure, 95% sure that between 2% and 12% of students did not achieve the minimum grade. Let us move on to problem 2C. Problem 2C. We want to estimate the true average final exam grade to within 5% and the true proportion of students not achieving a minimum final grade of 40% to within 0.1. With 99% confidence, what is the smallest sample size that can be used to satisfy both criteria? Let's begin by highlighting the information they give us. They tell us that the final exam grade has to be within 5%, and the proportion, or true proportion, has to be within 0.1. And they also give us the confidence level of 99%. So this question is giving us two criteria, therefore we're going to have to do the math twice, once for the final exam grade and once for the proportion. Let us begin by rewriting what they gave us. For the final grade, they give us an error margin of 5%. And for the proportion, they give us an error margin of 0.1. Both criteria use the same confidence level of 99% confidence. Therefore, they must use the same alpha. Alpha equals to 1 minus 0.99, which gives us 0.01. Then we have to divide it by 2, since the formulas require it, and that gives us an alpha of 0.005. And we have to find a z-score equivalent to an alpha of 0.005, which would be the same thing as going in and look up a z-score value equivalent to 99.5%, which gives us a z-score of 2.575. And now that we have all the information we need, we can plug it into the problem or into the equation. We'll start with this one for the average grade, and that'll be a z-score of 2.575 times the standard deviation, which we found in the previous problem, which was 7.5, over the error margin of 5% squared. And that'll give us a value of exactly 14.92, which we can have a point of a grade, so we have to round up to 15. And that's our answer for this criteria. Now we'll move on to the second criteria, which is based on proportion. The proportion of students who failed, we found in the previous problem, was 0.07. 1 minus 0.07 times the same z-score, 0.575, over our error margin, which is now 0.1. We square root that second part of the problem, and we get a value equivalent to 43.7, which we have to round up to 44. Which means for criteria 1 to hold, we need 15 grades, or a sample of at least 15 students. And for criteria 2 to hold, we need a sample of at least 44 students. Since the question is asking us to find the sample size that satisfies both, we simply pick the largest of the two. And we can write, in order for both criteria to be satisfied, we would need a sample size of at least 44 students. Let us move on to problem 3. Problem 3. Mark Simmers, owner of Aurora Restaurant, is considering purchasing new furniture. To help him decide on the amount he can afford to invest in tables and chairs, he wishes to determine the average revenue per customer. The checks for 9 randomly sampled customers had an average of 1830 with a standard deviation of 630. A. Construct a 95% confidence interval for the size of the average check per customer. Before we begin, let's highlight the information they gave us. They tell us that the average is 1830 with a standard deviation of 630. The sample size is 9, and our confidence level is 95%. Since n is equivalent to 9, which is clearly not greater than or equal to 50, we cannot use z, we must use the t-table, which the formula for is right here. Let me highlight that a little better. And the only real difference is that this formula uses t in place of z and s instead of standard deviation. Now, we know that the average is 1830, and our standard deviation, now denoted as s, is 630. Our confidence level is 95%, which means our alpha is equivalent to 1 minus 0.95, which gives us an alpha of 0.05. However, the formula requires us to divide it by 2. and that gives us an alpha of 0.025. And now a new step is that when using t-tables, you need to find something called degrees of freedom. And degrees of freedom are often denoted as df, and all you have to do is take your n minus 1. In this case, our n is 9 minus 1 gives us 8. Using these two values, this value here, we can go find our t-table value, or our t value. Here's our t-table, and what we have to do is, we found that our degrees of freedom is 8, which puts us in that row, and we know that our alpha per side, or per tail, is equivalent to 0.025, which is this column. We go find the matching value, which is 2.306, and that's our t value. Now that we have all the information, we can plug it into the formula. 18.3 plus or minus our t value of 2.306 times our standard deviation, 6.3, divided by the square root of n, which is 9, gives us an interval of 13.46 and 23.14. Again, this means that we are 95% sure, or 95% confident, that the real average amount of money spent per customer is between 13.46 and 23.14, based on our estimate, or our sample mean, of 18.3. And we can just write that out in a final sentence. We are 95% confident that the true mean is between 13.46 and 23.14. Now let's go over B. B simply states, what assumptions is needed to be made in part A? Well, that's a simple answer, and that deals with all confidence intervals. In relation to this class, all confidence intervals is based on the assumption that the sample or population is normally distributed. Let us move on to part C. Problem 3C. Mr. Simmers conducted a second survey in order to determine the proportion of customers that spent over $20. In a random sample of 80 customers, he found that 49 of them spent over $20. Construct a 97% confidence interval estimate of the proportion of customers that spent over $20. Let's highlight the important information he gave us. It tells us that the sample size is 80 customers, and that he found 49 of them spent over $20, and the required confidence level is 97%. Right away, we could find the proportion, which would be 49 over all the people he surveyed, 80, and that gives us a proportion of 0.6125. We can also find, based on the confidence level of 97%, our alpha. Our alpha is equal to 1 minus 0.97, which gives us 0.03, divided by 2, since the formula requires it, and that gives us a value of 0.015. And now we need to find the z-score. Z-score equivalent to an alpha of 0.015, which gives us a value of 2.17. And we also have our sample size of 9. Now that we have all the values needed, we can plug it into our equation, which would be 0.6125 plus or minus 2.17 multiplied by the square root of 0.6125 times 1 minus 0.6125 over Rn, which is our sample size, and that gives us an interval of 0.4943 and 0.7307, which basically means that we are 97% sure that 0.4943 and 0.7307, we are 97% sure that between 49.43% and 73.07% of all customers spend at least $20. We'll put that in writing. We are 97% confident that 49.43 to 47.07% of all customers spend at least $20. Let us move on to part D. Problem 3D. What additional sample size would be required in part A if Mr. Simmers would like to be 95% confident that the maximum error in his estimate would not exceed $1? Therefore, based on the values we got previously in part A, we know that the standard deviation is equal to 0.63, and in this case they tell us they don't want the error to exceed $1, which means E is equivalent to 1. All we need to find is our z-score, which firstly we must list the confidence level, 95% confidence, find our alpha, which is equivalent to 1 minus 0.95, which gives us a value of 0.05, divided by 2, since that's what the formula requires, gives 0.025, and the z-score equivalent to 0.025 is equal to 1.96. And to find this value, we have to go look up a z-score that left 97% to the left of it. And now once we have all our values, we can simply plug it into the equation. So n equals to 1.96 times the standard deviation of 6.30 over our error margin of 1, and then square the entire problem, and that gives us an estimate of 152.47 customers. And since you cannot have point of a customer, you can round it up to 153, and that means in order for his estimation to be accurate to $1 with 95% confidence, he would have to sample at least 153 customers. That's it for this chapter. Thank you very much, and I hope to see you guys next time.